Alright, this is a demonstration video. This is our prototype. This device is a capacitor analyzer. It is a piece of equipment that is able to measure capacitance and equivalent series resistance of electrolytic capacitors with a very high degree of precision. This device was developed during my master degree course at Unicamp, at the electrical engineering faculty. My supervisor was Professor Hudson Zanin, and I am Edson. I am a master degree student, and we developed this device in order to measure capacitance and ESR of capacitors with a very high precision and accuracy, okay? I'm gonna turn it on here, okay? This is our unit, okay? But before showing some results, I'd like to remind you some basic definitions, okay? When we have an ideal capacitor, okay, this is the model of an ideal capacitor, a capacitor that exists only in books, right? In textbooks. A capacitor that has only capacitance. But in fact, when you have a real capacitor, something like this happens, okay? Like every kind of component, capacitors also have resistance, electrical resistance. And the total series resistance can be modeled with this model here, a capacitor in series with an ESR. ESR stands for equivalent series resistance, okay? And the main goal here is to measure the capacitance and the ESR with a very high precision, okay? The main problem of this measurement is something like this. Look, the capacitance and the ESR, okay, are inside the capacitor. That's the problem. So you don't have access to these elements individually. So it's impossible to make a measurement like this, okay? It's impossible to use a capacitor to measure only the capacitance and an ohmmeter to measure only the resistance, okay? This kind of thing is impossible. So you have to devise a way to measure these quantities, both capacitance and ESR, in an independent form, right? So that's what our little equipment does, okay? It measures capacitance and ESR in an independent form, okay? We tested this equipment. We compared its results with more expensive equipments like potentiostats with charge-discharge methods, okay? And the results agreed completely, okay? But there is a very simple way to show that this device works properly, okay, without having to use a so expensive equipment, okay? That's what I will show you now. Okay, so our first experience will be like this, okay? Here I have a 100 microfarads electrolytic capacitor. It has a working voltage rated at 25 volts, right? And I'm gonna introduce it in our unit and measure its capacitance and ESR, right? The capacitor was inserted in our unit, and the measurement will start in a few seconds automatically. It measures the capacitance and the ESR, and it shows the results directly on the display, okay? So for this capacitor here we have, exactly 100 microfarads, and 0.43 ohms, okay? It shows also the deviations, okay, the uncertainties in the measurements, okay? So here we had, okay, these values, right? Okay, but before continuing, there is a way to show that these measurements are really in agreement, okay, with the expected values. Look, the capacitance, of course, was exactly, okay, the value that was written on the body of the component, okay. But the question is, how about the ESR? Okay, the ESR was 0.43 ohms. Okay, so how do we know that this value, okay, is really correct. Okay, so let's see, okay, this figure here, okay. So here, we measured, okay, the capacitance and ESR, okay, and now what we're gonna do now is I will connect in series with our capacitor, okay, a non-resistance R0, okay. Here I have a resistance of 1.2 ohms, right? A precision resistance of 1.2 ohms, okay. And if our equipment is working properly, the capacitance that will be measured, okay, with these resistors in series, will be exactly the same. Not exactly, okay, but quite near the same value that was measured before, okay. And the new ESR will be the ESR that we had before, plus the 1.2 ohms precision resistance, okay, that we will connect in series, okay. Okay, so let's connect the resistor and the capacitor and see what the equipment says. All right, guys, so as you can see here, we have the same capacitor now in series with a 1.2 precision resistance. Let's see the new values that our equipment will measure. Let's see. So that's it, guys. Take a look. So we have basically, okay, the same value, okay, 100 microfarads, okay, and the new ESR is 1.65 ohms, right? So it's the expected value. Okay, guys, so now let's go to the second test, okay? In the second test, we're going to measure two capacitors, okay? First, we're going to measure this guy here. It's a 22 microfarad electrolytic capacitor, okay, with a voltage of 450 volts, okay? Let's see what our equipment will measure, okay? Guys, so let's see. The equipment will measure this capacitor now. Let's see the values that we have here. It's measuring already. So we have the capacitance is 21.3 microfarads, and the ESR is 1.64 ohms, right? Okay, now it's time to measure this other component here, okay? It's another electrolytic capacitor of 15 microfarads, 200 volts rating. Let's see the measurement, right? Okay, the capacitor is already connected, and let's see the result that our device will give. Let's see. The cap was measured, the impedance also, it's calculating everything, and we have 15.1 microfarads and 1.33 ohms of ESR, okay? Okay, guys, so here we have, okay, our two capacitors, okay, with its values. This is the capacitor number 1 and capacitor number 2 that we measured, okay? So now what we're gonna do, we're gonna connect these two capacitors in series, okay? So if our equipment is working properly, and if it is measuring the capacitance and ESR in an independent form, okay, the capacitance that will be measured, okay, will be like C1 and C2 in series, okay, so it's like resistors in parallel, so 21.3 microfarads and 15.1 microfarads in parallel, we will expect 8.8 microfarads, okay, and the ESR, of course, will be in series, okay, ESR1 plus ESR2, and then we're going to have 1.64, 1.33, we're going to have about 2.97 ohms, okay, something, okay, that is approximately this value, okay. So let's see if we're going to have a result at least near these ones that are expected, right? All right, the capacitors are connected in series, as you can see here, okay. And let's see now if our device will lead us to a very nice and expected value, okay. So that's it, 8.74 and 3.01 ohms, okay, right, okay, 8.74, 8.8, 2.97, okay, so that's it. So the values are very close to the expected ones, okay. So that's it, guys. This is our capacitor analyzer, okay. I hope you liked the the equipment, okay? And I hope that you enjoyed this video, okay? Thanks a lot.